No, 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 no.
Clearly people don't know the benefits of ozone. So is ozone an element? I can answer that right now. No. Ozone is not an element. So what is ozone? It's the reason we aren't living in caves or have a sunburn after 5 minutes going outside. The triatomic form of oxygen that's mainly found in our stratosphere is pale blue in colour and a gas. Ozone is predominantly formed in the atmosphere. Here's an image that depicts the formation of ozone. Let me just load up a laser pointer here. There we go. Here we have a highly energized photon, bit of UV radiation hitting the double bond in diatomic oxygen. Here the diatomic oxygens split and just go to single oxygens. These then collide with other diatomic oxygen in the atmosphere due to it being making up about a fifth of Earth's atmosphere. When they collide, they form ozone. On the left here, I have an image that shows the stopping power of the ozone layer. The concentration of ozone varies with altitude. The highest concentration is between 30 and 35 kilometers, with an average of 8 molecules of ozone per million molecules. About UV radiation. When it enters Earth's atmosphere, it has a wavelength of 200 to 400 nanometers. On this image that I've got loaded up, it shows that it's got vacuum UAV, which ranges from 100 to 200 nanometers. We don't live in a vacuum, so I'm not including that on this list. UVC is the shortest wavelength of all types of UV, therefore having the most energy. To calculate the energy of stopping power of ozone when it comes to stopping UV radiation from hitting the planet, we can work it out using Planck's equation and the speed of light equation. If we rearrange one to find V, we can sub it into the other. Once we have E equals hc over lambda, we can rearrange to make lambda equals Planck's constant times speed of light over energy, wavelength required to be absorbed by the bond in ozone. When you put all the numbers in, Planck's constant, speed of light, number of, Avogadro's number, and the bond energy of ozone, you find that the wavelength required to break those bonds is roughly 330. Anything smaller than 330 is absorbed, and therefore that's why we see pretty much all of UVB stopped in the atmosphere and all of UVC stopped, while a lot of UVA still comes through. Ozone can commonly be found outside of the stratosphere. It can be found near the surface of the Earth. There are many different ways of forming it. We have ways, man-made ways to form it. One way is the corona discharge method. What happens here is pure oxygen is passed through a tube with high voltage on one side and, well, no voltage on the other. It's grounded. The oxygen passes through, and due to the electrical discharge, it forms ozone with a pretty good efficiency rate on the other side. But when it's down lower by the planet, it acts and interacts with other molecules in air, such as nitrogen oxide, to form photochemical smog. Now, pretty sure we all know what smog is, and it's not good. The background picture is a picture of Los Angeles when it was hit by a huge smogging, and you don't want that. So if you've got any questions, any interest, feel free to watch it back, watch it again. You can enjoy it. And if you've got any more information you want, you can look it up or you can email me.